All right, chickens. We're in 6.5, solving linear inequalities. Sweet. We're just going to go through these pretty quick. So how do we find solutions of inequalities? Well, we're trying to tell whether an ordered pair is a solution. So we're asking, is 7, 3, x is 7, y is 3, is this a solution to this? Well, plug them in. So if we say, all right, well, 3 is less than, plug in your x, which is 7, minus 1. Right, we just said, here's my x, here's my y. Is this true? Well, let's see. Is 3 less than 6? Yeah, that's true. So this whole thing is a true statement. Yeah? Excellent. So we want to see if this is a true statement. Is 4, 5. Does that make this inequality true? Pause the video now and try it yourself. Pause. I said pause. Good. Excellent. So, let's check it out. You plug in 5 for the y, you plug in 4 for the x, and you see if this side is greater than this side. Well, let's see. 4 times 3 is 12. 12 plus 2 is 14. And is 14 less than 5, or is 5 greater than 14? No. So 4, 5, not a solution for this inequality. Sweet. Moving on. Great. So we want to be able to graph a linear inequality with two variables. Yeah? So I want to be able to graph this. It's got a y and an x. It's an inequality. So first thing we got to do is solve for y. So we can graph this line. So if we solve this, we add 4 to both sides. So you end up with y is less than 3x plus 4. Sweet. So this is our equation. Awesome. And now we got to graph the line. Hey, don't forget to use a solid line when we've got greater than or equal to, less than or equal to, and a dashed line when you use greater than or less than, right? So in this case, we're going to be using a dashed line because the numbers on the line aren't part of the solution, okay? But we know this passes through, the y-intercept is 4, so it passes through right here. Yeah. Here's 4, and then it rises 3, rises 3, 1, 2, 3, runs 1, bing, and so that's our line, but now we want to extend it forever. Ing, ing, sweet, there's our line, okay? We need to shade this, okay? So we got to shade above the line for greater than and below the line for less than, right? How do you check? Well, pick a point. So I'm going to pick this point, 0, 0. Yeah? So I want to say, hey, does the point 0, 0, is this a solution? Yeah? So 0, 0 is right here. I want to know if all of these points over here are solutions or all the points over here are solutions. So plug 0, 0 in for your original equation. So now we've got 0 less than 3 times 0 plus 4. Well, let's see. Is 0, let's see, this is the 0, and so we really have 0 is less than 4. Is that true? Yeah. So this is a solution for this inequality. So we would take our pen and we would shade this side. Like this. Sweet. Great. Moving on. Okay, we're going to graph the linear equations with two variables. You try it. We got 3x plus 2y greater than or equal to 6. Right? Our step 1. Well, pause it now to try it. Pause. Cool. Okay, so solve for y. Well, this ends up being 2y greater than or equal to negative 3x because we subtracted it from both sides, plus 6. Divide by 2, you get y is greater than or equal to negative 3/2 x plus 3. Okay? So this is greater than or equal to, so I'm going to use the straight line, yeah? And we start at 3, 1, 2, 3 is our y-intercept, and then, so there's 1 point. We rise negative 3, 1, 2, 3. We run 2, 1, 2. So there's our next point, okay? Put a nice solid line through them. Wow, that's a terrible line. All right, step 3, pick a point. Let's find a nice line. ing, ing. So we pick a point. In this case, I'm going to pick 0, 0 again. Yeah? So here's, I'm going to pick 0, 0 and see if 0, 0 works in here. So does the point 0, 0 work in this original equation? 3 times 0, right? Plus, oops, plus 2 times 0. Is that greater than or equal to 6? Well, 3 times 0, 2 times 0, they're both 0. So is 0, is that really greater than or equal to 6? No, that's not the case. So this is not part of the solution, so the other side must be. So we have to shade this other side. Shade the side with not 0, 0. So we're going to shade this because all of these, all of the points over here make this equation true. Let's try that out. Let's pick this point. This point is obviously in the shaded region. It's 1, 5. So we want to see if 1, 5 makes that true. Well, it would be 1, I'm going to put the x in here, so it would be 3 times 1 plus 2 times 5. And I want to know if that is bigger than or equal to 6. Well, 3 times 1 is 3, and 2 times 5 is 10. So is 13 greater than or equal to 6? Yeah, dude. Ching, that's true. That's why this is in the shaded region. Yeah? Cool. So step 4 is shade it. Yo. All right. Problem solving. Michelle can spend no more than $7.50 on a text message each month. Her mom gets very mad if she does. A picture text costs $1.25 each, and a written text costs $75 each. I want to write a linear equation to describe all of the situations possible. All right, well, let's try this out. Write a linear equation to describe the situation. So 7.5, she has to be, is her maximum, right? She can spend up to that. She can spend no more than that. So she can spend greater than or equal to that. And we can spend $1.25 on each picture text and 0.75 on each normal text. Let's put t. I'm going to put a 0 so we know that's less than 1. Cool. So there's our equation. All right. Well, let's call one picture and one regular text. Let's go p on the side and t on the bottom. Cool? All right. Well, graph this. Okay? There are a number of ways to graph it, but a pretty easy way would just be to solve for p as it seems to be y. Yeah? So we do 7.5. So you'd say, all right, well, 1.25 p got to be less than or equal to 7.5. Oh, my underline. 7.5 minus 0.75 t. Yeah? Great. We just subtracted that from both sides. Okay, cool, cool. So, we're going to keep rearranging that by dividing by 1.25. Divide both sides by 1.25. So 7.5 divided by 1.25 is 6. So this guy is just 6. And 0.75 divided by 1.25 is a 0.6. 0.6. Great. Okay. So if we're true math nerds, we're going to want to switch that around. But I think it's okay for now. So we start at 6, right? That's our intercept is 6, and our slope is negative 0.6, right? And 0.6 is really just the same thing as 6 over 10, right? 6 divided by 10 is 0.6. So rise 6, rise, I guess this is negative, so rise negative 6, run 10. So starting at 6 up here, rise negative 6, 1, 2, 3, 4, 5, 6, run 10. Zoop. So there's our line. Sweet. Now, we want to graph the solutions. All right, well, let's see if 0, 0 works. 0, 0 is an easy one. If we make 0, 0, we put a 0 in here, we put a 0 in here, this becomes 0. Is 0 less than or equal to 7.5? Yeah, okay, so this point works. So all of these work too, okay? These might not work because they're negative. You can't really send negative text, so in this context, our negative answers don't really make sense, but all of these do, okay? So give 5 different combinations of texts and pictures that work. Well, let's see. She could send she could send nothing. We know 0, 0 works. If she sends no text, she's kind of boring, but she is under her budget, right? She could send 10 texts and no pictures. She could send 6 pictures and no texts. She could send 5 texts and 1 picture, right? She could send 4 texts and 2 pictures. Any of these combinations work for her, right? Any of these intersections. Can't really send a fraction of a text. Suppose you could just not have a lot to say, but all of these points, chunk, 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 and all these on the lines, boom, 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 boom. Any of those are solutions. Cool.